Dave opened up and said that if you're here to listen about Hive, you'll be sorely disappointed it wasn't a talk or a panel series of presentations on Hive. Personally, this has been an incredible series of talks. I think it's going to be an amazing panel. Just by way of introduction, I mean, most people study databases in school. I studied database management systems in school as well. I like to think I learned databases from folks like Mike and Dave. I spent a number of years at Vertica, helping to build, helping customers to install, helping customers to use. I think I learned a lot from Dhruba and the Facebook team when in 2007 it was very clear Vertica was not ready for what Facebook needed to do. I learned a lot from Daniel in 2009 when it was increasingly clear that Vertica was ready for what Zynga needed to do. And I think from Mike when he was at eBay, I learned very clearly that if you're dealing with multinational corporations, internationalization is a very important feature in the database. And then I did the unthinkable. In 2010, I moved out west. I joined Cloudera and got to see a little bit of a different perspective. Rather than focusing on the most extreme performance you could get for structured data load, for schema design, for disk optimizations, for very fast queries, we were dealing with a slightly different set of problems. And what I'm hoping to talk about for the next 18 minutes and 45 seconds is a big picture view of what I've seen from my days at Vertica, from my days today at Cloudera in terms of how data centers are evolving when they think about data management, the problems we have today. And I'll leave with some parting thoughts, hopefully, to seed the panel about where things might be going. So Mike convinced me, certainly, and I think the rest of the world about 7 years ago, that if you have a focused a solution to a problem, you can probably do better than some generic engine, right? Declaring that the age of one size fits all was over. And I think you can see as a result, and I'm just taking Gartner Magic Quadrant. I think when I counted, there's probably 2 to 3 times the actual number of systems in existence. But if you look, since Mike's prediction, and they didn't publish a Magic Quadrant in 2009, but if you look at Mike's prediction, it has certainly come true. There are more systems, even through acquisitions, there are more systems than there were. People are increasingly building specialized systems to solve specialized problems. Big data is it's kind of a way of wrapping up and saying, I have a lot of specialized problems in volume, in data complexity, or in speed of data capture. The result, though, and what we've seen in the years since then, is a different kind of problem. I think Mike touched on this very eloquently, which is that if I have a lot of specialized systems that can solve specialized problems, and I have data that's coming in kind of a raw format, and I need to get it to a specialized system in order to most efficiently solve that specialized problem, I'm going to move my data around a lot. And this is indeed the kind of problems that we're seeing today. It's a different kind of bottleneck. It's not that any one of these systems can't be made efficient. It's that I now have a lot of data that's very complex, that's coming in from many different places very quickly, and I need to move it from one place to another in order to get a problem done. And sometimes the efficiencies of that are not worth it given the kinds of problems that need to be tackled, the time frames in which those need to happen. So the challenge, I can't get a view on this monitor. The challenge that we're seeing when people tackle big data with the one size doesn't fit all with the specialized engines is that a result is in these specialized engines, people are tending to keep data for less and less time, right? You're trying to max out the capacity of that system. You're trying to optimize for exactly just the problems you need. And keeping data that you might need for extended periods of time is actually less valuable than saying, I need to focus and optimize around what I can do with the capacity I have today. It also tends to be used for limited applications. There's obviously exceptions to that, but most systems we see when someone says we have 1 of everything or 5 of everything, each one of those is actually solving a different problem. There's a different application using a different specialized engine to solve a different kind of problem. It's difficult to integrate these to get a single view of everything. I think there's been a lot of good attempts at data federation, but ultimately if someone says, I want to know every bit of data that happened across the entire company because I'm interested in getting a holistic view of how we interact with our users and customers, that's still a very difficult problem to solve when you have thousands of applications and hundreds of different database management systems installed for different problems. And then finally, at the end of the day, when data no longer becomes immediately useful, because you are focused on the efficiency of a given system, the data gets archived, which, as we've seen with many customers, is basically a very expensive delete operation. Very few people actually bring data back from archive. So what is different in big data? We think of big data as effectively being unfiltered. It's not unstructured. Right? It's not that it's necessarily schemaless. It's just unfiltered. It's the raw data of whoever happened to decide to write a bit to disk or on the wire. That's what it is. Right? And you'll eventually get it to the point that it's structured or filtered. You'll eventually get to the point that it can answer specific questions. But at the very point of generation, that's kind of the big aspect of it for senses of big. This volume of data makes it very expensive to move around. Getting data from one place to another, I think, has been very clear that that's a costly operation. And the business that's very dynamic requires a lot of flexibility in that. So investing a lot of time in optimizing how data gets structured and how data gets moved around means that you've missed the window, as we've heard now from the past few presentations, of what the business actually needed to accomplish. So what does it look like today? And this is not a universal picture. It's drastically simplified. It's not that data doesn't move. Right? Data always gets generated at one point and gets put into another system. But the idea is to minimize data movement. And this is where we see things like Hadoop, specifically at its core, just HDFS, a place where you can shove all your data. If you're going to move your data, you want to move it as little as possible. And you put it in a place that it's basically going to live, and ideally can just live forever. And I don't know if this is true about Facebook. You guys don't delete. Facebook doesn't really delete data, or do you guys delete it? You do still delete data. So we're never going to catch up if you guys delete data. But ideally, it's a place that you can keep it for as long as possible, as cheaply as possible. And that just doesn't mean inexpensive systems. It doesn't just mean inexpensive software. It means that you don't have to maintain the systems at all. When you put a byte into HDFS, the byte's going to be there. If you never touch it again, it wasn't that expensive to put it in. If you touch it a few times, you didn't waste a lot of energy and time trying to figure out how it fits and how to optimize it. And then that data often moves into other specialized systems. EDW here kind of being a box in which there are often different systems inside, not necessarily a single database management system. So the key here, the center of this, obviously, and what I'm trying to focus on, is this little bit in the middle. If you have this ability to collect data, if you can create a data hub, it can become a data reservoir. Right? It can be some place where you throw all data and then figure out if it's actually useful or interesting, if it's worth moving to somewhere else. So this is kind of the evolution that we've seen over the past few years and why people have been adopting systems that seem like a big step backwards from a database management perspective, but actually end up being very useful when you have lots of specialized systems and lots of data to move around. The obvious question here is, does this mean that Hadoop is ETL? Right? Is it that MapReduce is ETL? And the answer is, it's good for that. We're actually seeing, if you look at the ETL engines, if you look at Informatica, at Talent, at Pataho, and many of the other ETL and data integration engines, they're starting to move from grids that were loosely coupled to network storage and compiling their ETL routines onto Hadoop as an actual execution environment, because the data is local to where the compute ends up being. So it is true that we see a lot of people using MapReduce and Hadoop in general for ETL. That's usually the initial application. You get started with Hadoop, you're usually trying to solve a problem where moving data around for heavy data lifting early in the process is a really good answer. The thing is that this is evolving. All right, and this is the very interesting change we've started to see. Next slide. This is the very interesting change that we've started to see, and I think Hive was kind of an early indicator of this, but it's evolving pretty rapidly, which is that it's not just, once you have data in one place and you've processed it, it's not just ETL that you want to do on this platform and on this system. Because now that you've taken all of your very raw data and you've kind of cleaned it up a little and refined it, if you can take another engine, and it may not be a MapReduce engine, if you can take another system and throw it on the data, why move the data? Right? And I think Mike raised this, but it's worth thinking about a bit. Right? So MapReduce itself, huge step backwards. If you're doing data management, absolutely. If you're doing ETL, it's probably okay. If you layer it with Informatica, now it's interesting. But if you start looking at the other systems that people can apply now that you have data sitting with local compute resources available, and the analogy I kind of give people is, what if your NAS could just run the database? Right? That's kind of what you get with this system. You can give it engines. The other thing that's interesting is it's not just open source software that's being brought. I used Informatica as an example, but there are now a lot of different engines that are being brought to bear. And in fact, if you look at the investment in terms of where the venture community has been focusing, where all the startups are in the Hadoop space, they're on other engines. They're on other capabilities. It's just like in the world of Unix and Linux, you got JBoss and Tomcat and WebLogic. Right? There's other kinds of application frameworks. There's other kinds of access methods. There's other tools for analysts that are being built that instead of trying to pull the data out, which is how you integrate with the one-size-doesn't-fit-all paradigm, they're trying to move the compute in. Right, so this is kind of the evolution that we see in terms of the ecosystem. Now, I'm well aware, and I've read in history books, I've seen to some extent in life, that this is a life cycle. Right? It used to be that a mainframe is where you put all your data and threw all your compute there, and then it made sense to distribute that. Right? And then it was an EDW. You had one big Teradata Oracle rack system, and you tried to move all your compute there. And then one size didn't fit all anymore, and then you had distributed. So this is not the end-all, be-all. I'm not saying that in 10 years we're going to still be using this model. But it's interesting to see that given the requirements that we have today, given the data that exists today, and the business problems that exist today, we are moving back into a model that is more towards centralizing data and centralizing access to that data. Than the one-size-doesn't-fit-all model that's been true for at least the past half decade or so. So I think we're going to have an interesting discussion on the panel. Personally, I kind of try to plot this trend. I didn't have enough time to actually do the plot over sufficient time. But what I do every so often, oh, sorry, this was my last summary slide. I think I've hammered this point away, and I'll leave more time for the panel. What I like to do is basically just do a big Google fight, right, and see kind of where it's trending. So that's my talk. There were tons of questions. I've got 8 minutes on the clock. I think a panel is better than me droning on about what I've seen. That's fine. Yeah. Thank you.